In the previous chapter, we were able to assign values to port A. We test this turning LEDs on. In this chapter, our goal is to make the LED blink. So let's see how we can do this with the knowledge we have. Well, if in order to turn the LED on, we assign a 1 to port A, the logic step is to assign a 0 to port A to turn it off. And because the PIC will reboot at the end of the application, the program will keep executing over and over, and we should get a blinking LED. Let's see if this is true. Open project 1 from the previous chapter and write this code. Compile the code, check for errors, and burn the code inside the PIC. Pause the video here until you try it. No blinking. The truth is that the LEDs were turned on and off, but the instructions are executed really fast, one after another one. And as soon as this line is executed, the next one is executed so fast that your eyes are not going to be able to see anything. In fact, the instructions are executed so fast that by the time you are starting to blink, the PIC has finished executing the code. So our program, with just few instructions, start and finish in no time. So what we do? Well, what we need is to add a delay in our code that allow us to see the LED going from off to on and from on to off. That is the reason why I'm going to introduce you to functions, so we can start to take advantage of some code that is already built in the C18 compiler. Not every single aspect of functions are going to be covered, but enough to start. So what is a function in C? Well, a function is a block of code that performs a specific task. It has a name, can return a value, and can be executed from different points in a program. A function can perfectly have been written by someone else, and we can include it in our code. Let's create a simple function that adds two numbers. First, the name of the function. These two variables are called arguments and are values that we pass to the function. In this case, the numbers that we want to add. This is the block of code to be executed. And the return value, in this case, the result of the addition. This is the type of the value returning from the function. In this case, an integer. When this program is executed, the execution starts at the beginning of the main function, beginning with these three variable declarations. Then our function is called, and the execution is transferred to the sum function. num1 and num2 are passed as arguments to the function. The variable result is declared, and the addition of the two values is performed. The variable result will hold the addition and is returned to the main program through the use of return. Then the function ends and the execution is passed back to main. The equal sign in the main program will assign the return value to num3, and the program will end. If we store this function in a file and call it add.h, the only thing we need to do in order to use it is to add a line with the directive include. The C18 compiler has an extensive library of useful functions that we can include in our code. I think you have guessed which one is the one that we are interested in, a delay function. Well, lucky enough, there is a function, part of the C18 compiler, which is located in a file named delays.h. Now, in this part, I need to explain a few things about how the delay is possible and how we can use it. Every microcontroller has a clock that regulates the speed at which instructions are executed. The clock is a constant train of pulses that are injected to the microcontroller. This can be done externally, or it can be built in the microcontroller. In the case of the PIC, you can choose any of these two options. But our kit uses the PIC's internal clock. This clock produces 8 million cycles per second, or in a more technical term, 8 megahertz. Each instruction inside the PIC needs 4 clock cycles to be executed. That is 0.5 microseconds. How fast is that? Well, think about this. Humans blink in about 400 milliseconds, which is less than half a second. So by the time you have finished blinking, the PIC is able to execute close to 1 million instructions. If we are able to count 2 million cycles without doing anything, we can introduce a 1-second delay between instructions. The delays function just do that. Count cycles doing nothing. The more cycles it counts, the more delay is added. The delay library, that is part of the C18 compiler, has 5 delay functions. But we're going to use just this function to create a delay of 1 second. Let's go back to the delays library. In order to use these functions in our program, we need to add the library's name using the directive include. Okay, compile this code and let's see what happens. Pause here until you have tried it. Great, now we have blinking. Remember, at the end of the program, the PIC reboots itself and the program starts the execution again. Now, in order to introduce more control in our code, we have to learn how to work with loops. So let's move to chapter 4.